The new Opel Zafira is the first new GM vehicle to fulfill the requirements regarding passive protection for pedestrians, which apply as of autumn 2005. The design of the entire front of the Zafira was optimized to take into account an encounter of this type. The measures necessary for this have a major effect on styling, package and body structure. A distinction is made between two different test methods. A lower leg impact. In a collision, the impacting leg is deliberately caused to rotate and rolls across the vehicle. This produces a minimized bending angle for the knee and minimized acceleration values. A head impact. The impact energy during head impact is absorbed by the targeted deformation of the components, which have been optimized in mass, rigidity and strength. The acceleration of the head and the head injury criteria, HIC, are reduced significantly. To achieve this, the following components were optimized. Soft foam in front of the aluminium bumper crossmember. Upper flexible bumper mounting. A lower bumper panelling area reinforced by a ribbed plastic insert. Optimized position and shaping of the headlights. Bonnet with restructured bonnet framework. Bonnet hinges designed to yield. Yielding bonnet and bumper brackets. Function optimized steel wing with yielding brackets. Sufficient deformation space under the entire impact area. Torsionally soft plastic service panel with preset braking points and yielding multi-part water deflector. Bracket with a yielding design for the contact switch of the anti-theft warning system. The outer sheath of the front body, which is deliberately designed to give way, requires greater care by mechanics during servicing work when in contact with the vehicle components affected. Supporting or applying excessive loads to sheet metal components is not possible, as otherwise the special retaining elements can be deformed. If parts of the Zafira front section have to be repaired or replaced, the design measures described can only be retained by following the technically correct procedures. For example, the upper front consists of 3 parts which are screwed to the front frame. This enables a reasonably priced repair if the front is damaged. To obtain access to the bolts, the front panelling and headlights must be removed. The precise procedure for replacing the upper front is described in the service literature for the Zafira B Group A. During production, both the left and right sides of the upper front are provided with 2 tacked spot welds. If maintenance work has to be undertaken, these tacked spot welds are replaced by a screwed fastening. The screwed fastening of the three-part upper front is only released if body repairs are necessary. In all other maintenance work, it is not necessary to remove individual part areas or the complete upper front. Due to the design measures to provide passive protection for pedestrians, wing brackets which are designed to yield are used to fasten the wing to the wheel assembly strut. This means that the wing flanges are unable to withstand loading, as was the case in the past. Conventional engine bridges can no longer be used at this point in the usual way. The weight of an engine suspended from the engine bridge exceeds the load limit specified for the wing brackets. As can be seen clearly here, the engine bridges currently available are supported precisely in this area. Therefore, the existing engine bridge MKM 883-1 must never be placed on the wing flanges of the Zafira B. This is the only way of excluding deformation of the wings and the brackets. Further information can be found in the Technical Innovations Zafira B or TIS 2000. In all cases, only tools approved by Opel may be used. The front wings of the Zafira B, integrated in the passive protection for pedestrians, are designed as screw-in components to allow a reasonably priced repair. They are manufactured from sheet steel and screwed to yielding buffer brackets to protect pedestrians in a collision. In addition, the wings are attached invisibly with adhesive at 2 points to enable the front doors to move freely in the case of damage in an accident. One is on a bracket above the additional indicator light and the other at the upper transition to the A-pillar. In the event of a repair, before the screwed joints are released, these bonded joints must be opened. The wing is removed as follows. First, detach the radiator grille, front panelling and headlights. Then take out the inner protective panelling of the wing. In petrol-engined vehicles, remove the activated charcoal canister. In order to remove the A-pillar window, take out the inner panelling. Then unclip the dashboard cover and remove the foam section. Now unscrew the 4 retaining screws and remove the A-pillar window. Unlatch the additional indicator light and disconnect the wiring harness plug. The guide rail, visible here, only has to be removed if the wing is being replaced. If the wing is to be reinstalled later, the guide rail can remain in position. Remove the panel between the wing and the external windscreen frame and cover the edges with adhesive tape to avoid damaging the paintwork. Heat a suitable cutting tool, for example a knife or saw blade, with a hot air blower. Insert in the gap between the A-pillar and the top of the wing and cut through the upper seam of adhesive. To cut the adhesive joint, protect the upper edge of the wing from damage with adhesive tape. Then, from above, through the gap between the wing and the A-pillar, lay a piece of cutting wire, approximately 1 metre long, from the glass removal system BO 46974, around the adhesive joint of the sheet metal bracket, and through the aperture for the additional indicator light, masked with adhesive tape, to the outside so that it crosses. The cutting wire must not become stuck between the bracket and the A-pillar. Now, attach a T-handle MKM 589B to both ends of the wire and cut off any surplus wire. Next, heat the adhesive compound from inside with an industrial hot air blower. And then cut the adhesive joint by pulling evenly with the two ends crossed. Now, with adhesive tape, mark the installation position of the wing for subsequent reinstallation. If the wing has to be replaced, the new wing must be adjusted to fit before the adhesive is applied and before actual installation. Using a suitable tool, now release the sealing compound at the bottom of the wing from the A-pillar. Unscrew a total of 9 bolts. And carefully remove the wing. Make sure that all the adhesive joints come apart without any deformation. To prepare for reinstallation, the remains of the adhesive from the inner wing and from the bracket must be removed without leaving any residues. Any old adhesive residues must be removed and pre-cleaned to allow primer to be applied. This primed surface is used for applying the new adhesive. All the other sealing surfaces, such as the underside of the wing, etc., are cleaned and coated with the appropriate adhesive or sealant. All the painted surfaces must at least be primed to enable adhesive to be applied. The dot of adhesive applied to the A-pillar window frame only has to be removed sufficiently to allow a new dot of adhesive to be applied without having to apply further joint preparation materials such as primer or base coat. Now, apply the polyurethane-based adhesive to the bracket. The primer must be completely dry before doing so. The drying time for the adhesive must also be observed. Then mount the wing so that it matches the markings and clip the wing panel onto the windscreen frame. Tighten the wing bolts, paying attention to the fixing marks while doing so. Now, clip in the additional indicator light, install the activated charcoal canister and the A-pillar window and the inner wing. Attach the headlights, bumper panelling and front panelling. Finally, close the bonnet and remove the marking strips.